Okay, so I actually showed you a demo last time, but I'm going to go through the code that that I used to break the code. Okay, so to compile the code, you just sorry, where's I compile? Oh, compile code looks like this. I put it here, so you can actually just use. By the way, you can use GCC to compile it. You can use G++ to compile it. Okay, this code. This code should be self-contained and there's no problem. And this code is very simple. It's essentially try to break the file and into pieces. But I want to emphasize again, you can actually design whatever you want. But the thing is that you need to design your HEO program corresponding to how you break it. Okay, that's the only requirement I have for you. You can use it and break it using okay, this is a requirement. Sorry, I have to make that clear. Is that the interface of program to use the program must follow this interface. Okay, you can specify source file means that which file you're going to break, and when you break them into pieces, that each of them should have some kind of prefix, so you know they are representing the chunks. And also you say you should be able to specify for each chunk what's the size. I mean, for example, last time I showed in the class, you can see that the prefix is my prefix. And so each of the chunk, I labeled it as a 0, 0, 1, 0, 2 to 0, 10, 11 chunks. And each of the chunk is, I think it's 64 megabyte. That's why the number shows a little bit more than 640 something, whatever, 6 million or something.
Professor?
Go ahead, please. Yes.
So is the number that is right next to your cursor, is that in bytes?
Yeah, that's in bytes.
Okay.
This is in bytes, right? This number is in bytes, yeah. Okay, so I essentially break this one. And the thing is that in order to show my HEO program, I use the diff to basically put them together. Okay, so what I want to show you is that just explain to you the code I gave you as a reference code, just see if you have any question, okay? So of course, my program, that the first part is the ARGV, ARGC related stuff. So I check whether how many arguments you have. This is the very typical C++ programming you have to deal with, okay? And of course, I just let you know, this is actually, I decide the chunk size. Remember I said the chunk size is in K byte. So that's why I take the fourth argument, which is ARGV3. Okay, by the way, it's ARGV0 is the command, ARGV1, 2, and 3. So the third argument after the command is the chunks in size. So here is something which you might or might not know is you can use a command called hw1 because everything received from ARGV is a string, is a character star. And therefore, I want to convert that to a real number. Then I use this function hw. Okay, I use the function hw, and then I times 1024 because that's the 1K byte. So that's why this should be the chunk size. And we try to run the programs, write the program always as defensive as possible. And that's why I check whether the chunk size is really valid. It means that it shouldn't be negative, and it shouldn't be because I don't know what people will enter in ARGV3, and also the file shouldn't greater than 1 gigabyte. Okay, so I'm actually give a limit in this program that the chunks, each chunk cannot be 1 gigabyte. Okay, I mean potentially in the future that the system is getting larger and larger, which I think is coming, and maybe the program should make it a little bit wider, means from 1K byte all the way to maybe 1 terabyte instead of 1 gigabyte. Okay, so that's this part. Just set up the chunk size, and then I'm starting using this Unix file system call fopen. I open the file, which is the source file, which is ARGV1, and I grab it as a readable mode. And after I fopen it, of course I check whether the open successfully. if it's equal to null, I know that that file doesn't even exist. Don't move on. Otherwise, you're going to get segmentation fault. And then inside here is a main logic. After you open the file successfully, and inside here, you're actually going to start to produce. This part is essentially what I did to produce that chunk's name. The chunk, remember, now I'm using argv2, which is the prefix. And I do malloc to allocate memory to say what's the file name I need to deal with. And then I can start to generate that name. And then this part is really just moving. If you see that this part is so, I move one time 8 byte. So you see that I read 8 byte from the source file, and then I basically write it back, okay? And then I just rewrite, and then after that, I'm done. So this is essentially the logic about how I actually breaking it, okay? Okay, it's not that complicated, but some of you might not be familiar with some of the system call, such as fopen, fread, fwrite, fclose. Okay, those are the things that, of course, I use malloc a lot as well. Okay, and that's it. That's the program. So this is really a warm up for you to, for those of you who are familiar with the file operation, that's what you need to. The only thing you need to take care from my heel is revert the process, but also you should check whether each chunk is valid at least in terms of their size, or maybe one of the chunk is gone. Then basically the healing process will fail that your program is supposed to detect that. Okay. All right, I'm actually going to stop here. My time is almost up. I'm going to open the floor for question.
Hi, Professor.
Yes,
I have a question.
Mm-hmm.
So we can use your my break, but we need to like write our own my heel.
Yes, you can use my break as it is, which means that you only need to write the my heel. Or you can actually modify my break to do whatever extra feature or extra difference you want. This is your choice. Yeah.
Okay, so this means like we can write my heel based on my break.
Yes, you can do that.
Okay.
Yes, you can do that. Yeah.
Professor, so
yes,
are we allowed? Can we use the IO library of C++ to write the program of
sure,
my break?
You can do that. You're very welcome to do that. You're very welcome to use C++ library to do that.
Thank you.
You're welcome.
So we can write this in C or C++, right?
Yes.
Because I'm not familiar with C++. So.
Yes, you can use C or C++. Here is I use C is because I know most of us are not familiar with C++. But if you want to take that opportunity to kind of try to learn from this book that has actually a nice introduction to the file IO, and feel free to do that. No problem.
Okay, thank you.
Professor, so the knowledge about like file IO, I think what's required for the part 2 of the homework 1 is on which chapter of the book?
Okay, let me actually check very
also
quickly.
I want to like read the book first and then do the part 2.
Okay, so let me tell you that the file IO is in chapter 17, the last chapter of the book.
Okay.
Okay, so chapter 17, I do want to say that this is my experience about learning programming. Don't use a lot about the book in the sense that you don't want to read the book from the cover to cover, then start to do things. I mean, I recommend if you could use the book as a reference or just read a little bit to a point that you can start writing program, and to a point you can compile your program, and then you see fail, and then you do that. Because there are just so many things. If you look at the book, is like wow, how many pages? 600 pages or something? 700 pages. there's a lot of information, which is even this book, 700 pages, hasn't covered. So I would say that don't waste yourself a lot of time before you start doing programming. My preference is that if you could, you should jump into programming immediately and then try to find out what you miss. You can ask me or ask Google, TA, and other student, and to help you to get to that point. Okay.
Okay, thank you.
You're welcome.
Um,
Yes.
you can go ahead. It's okay.
Are we allowed to write more other than chunks?
Sorry, I missed your first part. Brian, can you say that again?
Are we allowed to make more files other than just the chunks of the broken file?
That's your option. If you want to
Okay.
make other file, as long as you can heal them together,
Okay.
that's okay. Okay,
Right. Thank you.
you're welcome.
Excuse me, Professor.
Go ahead.
How do you grade these homework assignments? Because you said we can do a lot of extra things. I'm just wondering, like, if that, like, changes our grade in any way.
Okay. For homework assignment number 1, is pretty straightforward. For the part 1, I'll be able to see whether you submit the record successfully, right? So you will be able to get part 1, which is a 4-point, by just have a record in the log file. So that part should be very simple. And I don't think you can do anything extra over there. But for part 2, I think we will need to do, I still need to discuss with the TA, but this is probably going to be the grading, is that because the 4-point, 2 of the point, if your program will compile successfully, you have your make file, I can just make and run it. I mean, that's the 2-point. The other 2-point is I'm going to do a diff on the file. I'm actually try to break and heal whether they're the same. If they're identical, you got the other 2 points. So the rest extra will not give you extra, will not deduct. That's I think we will do.
Okay, thank you.
You're welcome.
Professor, I had a question. So
Yes, go ahead.
In my previous classes, I worked with C++ mainly, and I'm not familiar with the the malloc and the fread and the fwrite and all those commands. So what do you recommend I should do to get familiar with those?
Okay, so you are not familiar with fread and malloc, is that right?
Yes.
Okay, so here's my recommendation. For fread and fwrite, it might be okay. You can use whatever the C++ IO equivalent of IO. That's fine. But for malloc, I think you might need to try to pick up the malloc. I think in the textbook, actually, it talks about malloc. Let me see if the textbook. The reason I said malloc is important because if you take like operating system, it's all about memory allocation, dynamic memory allocation. So I think the concept is important. Just give me 1 second. I want to see whether we have that here. But by the way, I do want to comment on this note. It doesn't cover malloc. Dynamic memory allocation. Oh, it might have dynamic memory allocation. It is a subject for ecs36a as well. My experience is that usually the instructor pushed this topic until toward the end of the quarter because there are so many things to cover. I don't know whether that's the case for your experience, ECF36A or ECF30. So malloc is a topic that that you all make sure you understand because it's so critical for especially for computer science major want to do system programming. Therefore, what I suggest is that I will provide some sort of tutorial about malloc for you to watch. And if there is still some issue, I will dedicate one discussion hour, office hour, or whatever over Zoom to talk about this issue. Okay.
Okay, thank you. Yeah, that'll be very helpful. Thank you.
Yeah. By the way, Malloc is, I mean, if you listen to my lecture number 7, when I talk about the difference between multiple inheritance and what's the other, virtual inheritance, which is really the concept Malloc will need to be there. Even though if you're a C++ programmer, a lot of them are confused about the difference between virtual inheritance and multiple inheritance. And it's all to do with memory layout, memory allocation, which is the important topic. Okay. Reminds me when we get to that point, if people want to know more about that. All right. Okay. Do we have any other question?
Professor, what's the best way to contact you? Because I feel like I'm pretty behind with like a lot of these things. I'm a transfer student, and like the computer science courses that I took were kind of different from this. So what would be like the best way to contact you over that?
Okay. Okay, Arthur. I want to say this is that every time I tell students what's the best way to contact me, I start shifting to the other way. All right. So I'm not joking. I'm just sometimes it's just one channel is so much, and so let me tell you a few ways you can contact me. Of course, email. I should always respond to email. Sometime when I'm having some deadline, I might be a bit slow, but I think we should do that. Or Facebook message, the second one, but also you are welcome to post to the class Facebook group page. I do want to tell you and everybody else that when you feel you're behind, I feel that sometimes it's just email back and forth is really slow in reacting to that problem. So during that situation, I would recommend you directly try to make a one-on-one appointment with me. And we will actually be able to dedicate that time just between you and me and to see what's missing. Because the more information I know about you, the better I can help you. All right.
Awesome. Thank you so much. Yeah,
You're
I
very
really
welcome.
appreciate that.
You're very welcome. Yeah. So that's for everybody. And if you have any, you feel you need something, but you don't know between where you are now to the other end of the gap, you should get help. I mean, I'll be happy to help you. Okay. All right. Any other question?
Professor, I was wondering, I'm on a Windows 10 machine for the Unix commands that we need to do for the homework. Would just command prompt work?
No, command prompt won't work. So on Windows 10 machine, you really have two options. One is called hw1, one is called WSL, Windows Subsystem for Linux. I highly recommend you to use WSL. hw1 will probably survive for ecs36b, but it's not as updated. I mean, I highly recommend you to use WSL, which I don't know, Mia, I don't know whether you were here last time. I do have a lecture dedicated to, not only in the syllabus, I talk about installation, I do have I think a lecture talk about the configuration for WSL. So if you have any question installing or configuring WSL, we're here to help. Okay.
Okay. Where do I find? I saw like a list of YouTube videos, and I don't know where they were in Canvas. I can't find them now.
Okay. So let me actually share my screen again, and I want to show you a few things. Make sure you don't miss important information. Let me see. Okay, assignment. So this is a syllabus, and just to let you know that sorry, I have to skip this part. Okay, this part starting with the instruction for Windows 10 WSL, which is talk about how you can do this step by step. Okay, but I do have a video. Let me actually try to pull it out. This is what I provide, but I want you to see the video. I want to try to remember which one. Let me check. I think I do it here. Okay, let me actually just check very quick. Let me actually just check, okay? Yeah, this is the lecture. It's the title is ecs36b, lecture 02, object-oriented paradigm, number 2, plus demo. And around like minutes 25, 52, I start to explain some of the C++ compiler. First, I talk about just regular terminal, but then over here, I start talk about WSL. I think starting from here, I start talk about this is the WSL configuration. So once you install WSL, then what you need to do that. And you know what? I remember I have another section over Zoom. I actually show, oh, here. Oh, sorry, I found it. This one. You see that? This one is ecs36b Zoom 0406 Windows subsystem. So this one is actually okay, this one is the installation. Okay, sorry, forget about that video. That video is talk about how to use Visual Studio Code. But this video is actually talk about how to really install this system WSL and the Visual Studio Code on Windows 10. Okay, this video. I'll probably reshare that link to the Facebook. Let me just reshare that right now because otherwise I will forget. Let me just do that. This is WSL, Visual Studio Code, Zoom. Okay. Okay, so this should give you something you can work from. Okay.
Okay, thank you.
You're welcome.
Professor, I just had one last thing I'd like to talk about. So I downloaded WSL and everything on my Windows computer. It works fine, just fine for me. But I was wondering, like for the future classes, do you think it's better to have like work on a Mac, or do you think WSL should be fine?
I think WSL will be fine. To be honest with you, you don't have to use Mac. In fact, I think Mac you will only learn. I mean, this is my personal opinion. I think they're equally good, but for learning experience, I think having WSL, which is going to cause you some hiccup from time to time because it's not exactly 100% Linux, but that experience will help you to learn something. So I if I were you, I would stay with Windows 10 plus WSL.
Okay, thank you so much.
You're welcome.
Excuse me, Professor.
Mm-hmm.
I'm running Oracle VM VirtualBox on my computer for a Linux environment, and I was wondering if that would work because I have it from my summer course that I took at a community college.
Sure, it's fine. If you have a full-fledged Linux environment, that's fine as well. I mean, let me tell you the difference between WSL and you use Oracle, right? The VirtualBox.
Yeah.
Is that what you have is a full emulation about the whole environment. which is fine. Of course, it's 100% authentic to a Unix environment. The only issue with that is that the performance is going to be slower because it emulates every perspective of a Linux. So for just fulfilling the requirement of ecs36b, I mean, absolutely, that's great. But I just want you to aware of that performance difference. It's the reason we look at WSL. WSL is a trade-off between having the essential element in the Linux environment, and yet it actually gives you all the performance gain because it is not a full-fledged. That's why they can do some performance optimization. I mean, this is a topic for especially I mentioned for system programmer. They will be more and more aware of this, and hopefully later in the class, in your study, you will actually get exposed to more about those issues. Okay.
Thank you.
You're welcome. Okay. Any other question? All right. You all have a good weekend, and we'll see each other on Monday. All right. Take care. Bye.
Thank you, Professor.
Thank you. Bye.
Thank you, Professor. Goodbye.
Bye.
Thank you, Professor.
Thank you.